Are there any questions?
From the old test, I forgot what the question was.
Good.
But it was like you were in another planet, and then you dropped the ball.
So, like the master set question?
No, it's from your past test. I couldn't solve it, so let me pull it up.
Okay.
It's like the one from 2011. This one, so number 12.
12, so Strange Planet. Oh, it is like the master set.
It's from your past test from 2011.
Yeah, well, the master set questions come from past tests.
Oh.
And the Strange Planet would be the atmosphere. You still want to work through it, I assume.
Mm-hmm. And I keep getting like 1.14 meters. Then 1.14 meters.
All right, so we got 2 meters, 0.71 seconds. Decide to see how high you can jump. And it goes 1 point. All right.
In the master set, I broke it down into parts. All right, so he drops it 2 meters. And that was 0.71 seconds. And then he jumps to a height of 1.5 meters. The question, and this is still on planet X. And then how high does he jump on Earth? Okay.
I was like, mm-hmm.
All right, so from the first bit of information, if I take an object and I drop it, well, let's go through the setup here. So first thing, well, in order to figure out how high you can jump up on Earth, we need to know what his initial speed is.
Mm-hmm.
To know his initial speed, we need this information over here.
Yeah.
Well, in order to figure out, well, let's do it out more formally. We'll work backwards and justify. So we have on Earth. X, D, I, D final, and T. All right, so when he's jumping up on Earth to see how high he goes, what do we know of this problem?
Final velocity will be 0.
All right,
Acceleration is negative 9.8 meters per second squared.
so what did you just establish?
The direction for positive is up.
Okay. All right, I know 2 pieces of information here, I need 3. Well, the one thing that's going to be common between the strange planet and Earth is that. So we need to figure that out. So, one planet, one X, we have delta X, VI, VF, A, and T. So from the fact that he's jumping up 1.5 meters, what do we know?
1.5 meters. Displacement? Wait, I thought it was 2 meters. Oh, 1.5. He jumped up at 1.5 meters. His displacement is 1.5 meters from the ground to the top.
Yeah. So that would be what? Okay.
His
So what
final
have we now established?
positive is up.
Okay.
And then his final velocity is 0 because that's the peak height.
All right. Now, what we would really be helpful to know, we need one other piece of information. This is what we're trying to find here, so we're not gonna know that at first. Be nice if we knew what the acceleration was. So that's what we need to find. So now we go to the first thing, where he takes an object and he just drops it. Well, we're trying to find acceleration. What do we know?
The displacement is -2 meters.
And
The
what did we just establish?
positive is up.
Okay.
And then initial velocity is 0 because it was dropped.
And one other piece of information,
We know time.
which is,
47.
all right. Positive or negative?
Positive.
I hope so.
Time is something.
Really, it's changed. You assume time goes in one direction. All right, so we have this information. We now have three pieces of information. We can find the acceleration. Once we have the acceleration, we can plug into here, and then we can find VI. And once we have VI, we can go into there and we can find this. So, how do we find the acceleration?
It's
The
distance over time is speed, so
I used the displacement equals initial velocity plus acceleration times time.
oh yeah.
Wait, you used what again?
Displacement is equal to initial velocity plus acceleration times time.
Yeah, it's not one of the equations.
Oh, okay. Oh, I said
That would be final velocity, equation for
Oh,
final
yeah,
velocity.
I keep mixing those up.
Integrate. Oh, sorry. You got calculus, you do an antiderivative of what you said, you get the right formula. Which equation?
Delta x equals dx equals 5
So we have -2 is equal to 0 plus 1/2 negative g squared. The only force acting on it as it's falling is the force due to gravity. Therefore, the acceleration due to gravity, since we said up was positive, it would be negative little g. I'll put a little g sub x there because it's really the acceleration due to gravity on planet X. I know what that is. So this becomes -4 over 0.71 squared is equal to negative g. The negatives cancel out. And we are left with 8.
7.9.
7.93.
Meter per second squared.
So if I ask what's the acceleration due to gravity, the acceleration due to gravity is 7.93 meters per second squared. I believe on the master set, a lot of people choose up to be positive and they end up with a negative acceleration due to gravity. Or they end up with a negative acceleration, but the acceleration due to gravity, that phrase, acceleration due to gravity, is the magnitude of that. Anyway, we know acceleration now.
So we got a positive one, like a positive acceleration.
We got a +1 because I put a minus sign right there. I said the acceleration was negative little g.
So if we just did g, then it would be negative.
Yes.
And we just cut points off if we got a negative.
If you put down, If I asked what is the acceleration due to gravity, and you gave me a negative number, then yes, I can take off of that.
Because acceleration due to gravity can't be negative, but acceleration can.
Yes. So the acceleration negative 7.93.
It's negative for this one because it's technically slowing down as it gets to 0.
Yes, we said up was positive, so the velocity was positive, and slowed down, so acceleration should be negative. All right, so we have acceleration. So now we are in the middle over there. So now we're jumping up. We jump up to a height of 1.5 meters. I know acceleration and final velocity. What is the initial velocity?
So
We can
it,
solve for it now.
You okay? Which equation do we use?
the VF squared equals VI squared
Yeah.
plus 2 displacement times acceleration.
All right, so VF squared equals VI squared plus 2A delta X or S or whatever letter you're using today. So I have 0 is equal to VI squared plus 2 times negative 7.93 times 1.5. So VI is equal to 4.7 or so. Yeah.
4.96 meters per second.
If we had messed up on our signs and we had position and acceleration the same sign, we would have ended up with a negative under the radical, which would have been the clue that something was off. Also recognize that what we found right here is the initial speed. We have to interpret that and go, the initial velocity, it was up, therefore, given our convention, it would be positive. No vector symbols over these two in this equation. All right, so we have 4.96. So this is 4.96 meters per second.
Did anybody else get 4.96? I got 4.88.
You got 4.88?
I was doing 4.8.
Oh, yeah, I see what I did wrong.
Robin, you're leading me astray here.
I'm sorry.
You had also at 88?
Mhm.
Does anyone want to stand up to say something to Robin? Or ask him a question?
It's okay, Robin.
Okay. That's very good. Kind of you. I was just wondering if you were raised by the same set of wolves as I was raised. All right, so now we want to find displacement. What do we use now?
Same equation.
Okay. So we have same equation there, so I have 0 squared is equal to 4.88 squared plus 2 times negative 9.8 times delta x. So this guess is what I'm using here.
1.22 meters.
Is that you can't read my handwriting, or you got a different number?
I got a very different number. I got a very different number.
What'd you get?
Probably different. But 4.8 squared is 23.8144, and then plus the 2 times 9.8.
Oh,
Oh, it's negative minus. That's why.
you're not subtracting it though.
Huh?
No, because we need to get delta x by itself.
Oh, divide.
So first we subtract
Then
that,
I
and then we
divide.
divide by that.
Now I got
Okay,
I got the same thing.
okay. Welcome back to the fold.
it.
All right, so what, positive or negative?
It's
Positive. We jumped up.
What does the question actually ask?
Oops, I already lost it.
what was the question?
So
I'm
we're
looking at
carrying
it.
it up, so it should be positive.
I lost it. Give me a second.
What does the question actually ask?
It's asking for how high can he jump on Earth?
Yeah. So from a vector point of view, yes. It goes upwards. We said Robin established up was positive, and so therefore it should be positive. But the question is asking for a height here. I mean, how high up does he jump? So it's not asking for his displacement, maximum displacement, or anything like that. It's asking for how high he can jump. So it would be a positive number. So the actual answer is the scalar version of this, which looks a whole lot like that.
Okay.
Is it distance?
Yeah, it's a distance, because he's going straight up. Or magnitude of displacement, probably more universal there. Do you feel like you're more complete as a human being?
Yes.
Any other questions on this problem? This was from the fall 2011?
Yes. The full test went from A to B.
Okay. That was one of the first tests I gave at the school.
How did everybody do on
Oh yeah.
I don't remember, but I have a spreadsheet somewhere where presumably I could look it up if I had to. I assume it's standard, the median was somewhere around 50%, standard deviation of 20.
So the highest probable was a 70?
No. The highest would have been 100%.
Yeah.
The median is usually somewhere around 50%.
And then you said standard deviation of around 20, right? And then you said standard deviation of around 20?
Yeah, it's within one standard deviation of the mean, 2/3 of the grade should fall within one standard deviation, approximately. It's 68%, I think, officially, or close, somewhere around there. 50% is not failing.
Fear.
Ritika?
Is this week's Monday lab due the 17th?
because we
Where are we? Are right there. It is due the 18th.
So
The next time we have lab. I should have done that with Labor Day, but I messed up. But the labs are due the next time 8 week or 16 week, it's less of an issue.
Yeah.
I would like them by the 18th. There'd be both labs.
You want me? Okay.
Yeah.
So,
There shouldn't be anything due, I mean, there are occasionally exceptions, but there shouldn't be anything due on days of tests. Other questions? just trying to interpret your look, whether you don't have any more questions or if you're just afraid to ask. Some of both?
Yeah, you could say that.
They said the median of the test was like a 50%.
Yeah.
What would that be like for their grade?
Let's see.
Okay.
Here's my philosophy. If I gave you a one-question quiz and you got 100 on it, A. If I gave you a second one-question quiz and you just had an absolutely horrible day and you failed it, F. Average of an A and an F is a C. But if I gave you both at the same time and called it a two-question quiz and you got one right and one wrong, should your grade be different? Well, my philosophy is no, it would still be a C. So that's roughly
Okay.
how it goes. Yeah, the averaging of 0 and 100 to get 50, and that just, well,
The wording made it sound a lot more harsh than it probably was.
oh, yeah. Every grading system has issues, so I try not to penalize you based upon something arbitrary, like, oh, you had an 89.9 average. Sorry, that's not an A. Yeah, I can't tell the difference between an 89.9 student and a 90 student. So I don't like people who are separated by a single number to have different grades.
Yeah.
That's the other part of the philosophy. All right. In the absence of questions, I was going to pick up on chapter 6. All right, chapter 6. So what I'm going to do is I have a stopper attached to a